Our second lecture for this week is going to be on transdisciplinary design. And this is from Dr. Eritas's textbook that's also recommended reading for the course. You're not required to buy the textbook for the course, but from the textbook, we're going to cover in the slides what's important for your design projects and what you should know. So transdisciplinary design is a way at looking at engineering design where your relevant problem field has many uncertainties, the concrete nature of the problems can be disputed, and you really need to take into account the diversity and complexity of society and regulations and everything that could be affecting your product and your consumer. And you can read here in more detail their working definition, and also, as I said, you could look in the textbook as well. The expected results of a transdisciplinary design approach are emphasizing teamwork. So no one engineer is going to be able to solve every aspect of your problem. You might have electrical engineers working with chemical engineers, working with mechanical engineers, and even needing to bring in business specialists and also sociologists and human communications experts as well. So you also need to consider both academic experts and non-academic experts on your problems. And you want to develop shared concepts, methods, processes, and tools. So the TD approach, transdisciplinary approach, teaches students to see collaboration outside the bounds of their professional experience to make new discoveries, explore different perspectives, express and exchange ideas, and gain new insights. So research characteristics in transdisciplinary design, you want to relate real-life complex problems to specific problem solving, eliminate disciplinary boundaries, participate with academic and non-academic stakeholders. So when you think about this in the context of a medical problem, such as helping somebody's mobility, you have the specific person you're trying to help, and then you can think about more of the ecosystem of how is this technology going to affect hospitals? How is it going to affect distribution of the product to people? How are people going to use it and integrate it in their daily life? How are people going to use it, to maybe improve their health condition as well? So there's more aspects than just the mechanical engineering you should consider. And this is going to help you form diverse perspectives and problem framings. You want to look at it as a whole rather than just a reductionist approach of solving math problems. And you need to generate knowledge and do customer research to investigate your specific problems. In transdisciplinary research, they really emphasize teamwork. And so this is something I really like to emphasize in the course, and we're going to be touching on this more in later lectures. But you want to focus on achieving results as a team. The decisions you make on your project should be to the benefit of the team and the consumer rather than your own needs and agendas you're trying to push. You need to hold each other accountable for delivery according to the plans and have high standards for each other. So this is why we do the peer evaluation in the class, because everybody needs to be contributing to the project throughout the semester. We need to commit to decisions and plan of actions. So that means once your team comes to a decision and you're moving forward with it, you shouldn't be constantly attacking your team because they didn't pick your idea and saying, well, our design could be better if we had done this instead. And on that note, you need to make sure as you're moving forward as a team that you do take into everybody's perspective so you keep that cohesive teamwork alive. And to do that, you want to openly discuss conflicting ideas. You want to have dialogue and debate, and this is why we take a lot of class time to have discussions, and also why I'll join in on the discussions and I can help you as a team mediate your design decisions. But me as an instructor, I'm not going to go in and tell you the decision to make. That's part of your experience and your job as a designer to make your own decisions as a team. And also you hold each other up. You have vulnerability in sharing your ideas, but you're also encouraging of other people on your team, and you also give credit where credit is due, and really recognize the contributions of each member. And the process that we're going to look at really quickly for conducting transdisciplinary design early in the design process is an interpretive structural model tool. And so this is an approach of understanding from high-level factors what could be driving decisions in your design. And so we're going to look at this for a case study of an eco-village, which is a project that combines architects with engineers, with sociologists. And so when creating like a small town that's going to be sustainable, you need to recognize what factors could be affecting it. So policy and regulations, environmental issues, economic dimensions, you could have technologies in green buildings, you'd want renewable, sustainable energy, you'd want it to be self-sufficient, you need some kind of transport within and outside of the village, you need to think about the social issues, how are people going to interact, and diversity in that you don't want everybody to be the same because you want people to have different roles and contribute in different ways. And so this is what you need to do for your design project and your presentation this Friday is come up with the factors affecting your decision or your engineering design. And then I'm going to go through here. If you choose to do this, you can go to the atlas.org and carry out this tool to solve a matrix to see how these factors interact. And so I'm just going to briefly talk about it in the next couple slides. And if you look at the PDF on Blackboard, you can see a more in-depth example of how to carry out solving the matrix to see how these factors influence one another. Or like I said, you can go to the atlas.org and then you just put in your factors and it'll solve it for you. And that can be a really valuable tool early in the design process. But at least at the minimum, you need to be recognizing these factors that are high level and could be driving decisions in your project. So when you go to the atlas.org or solve this, you would list out all of those factors, and then you can put an X, a 0, an up arrow, or a down arrow stating how these factors influence each other. So the X shows that they influence one another equally, and then the arrows point which direction they're affecting one another, and then the 0 means there's no correlation or effect between the variables. So that's why only the top half, the top right triangle of the matrix is filled out, because you don't need the redundancy on both sides. And then you can take from that matrix, you can solve and come to this plot here where it has these 9 factors and the arrows that's driving one another. So you can see on the left here, for instance, factor 9, there's no arrows going into it, into diversity. So that means when you make decisions concerning diversity for your design, it's going to affect other factors, but nothing is going to affect the diversity itself. So when we assume diversity is the different people in the village, you can see how that isn't going to be directly affected by something like green buildings. And so it's important as a tool to like reason through all of these interactions and see how it comes out in the matrix. But as I said, for your design project, if you just come up with the factors, that is sufficient for the course. And you can conduct, once you see that plot, what's called a micmac analysis that can also be done at the atlas.org automatically. And this puts those 9 factors into a matrix where it shows which ones independent, which ones link on each other, and which ones are completely dependent on one another or autonomous in that they don't really affect or are affected by another aspect of the system. So the independent factors, you can see that they would be driving other factors in the system, whereas a lot of the factors you're going to have are going to be interconnected in maybe non-obvious ways. And so this concludes this presentation. I'm happy to talk about this and discuss it a bit further, or you could look at Dr. Ertus's textbook. The Transdisciplinary Design Process is a really good tool for thinking about complexity in design. And we'll touch back on it throughout the semester. But as I said, for your project presentation this Friday. Just concentrate on the driving factors and how they affect your design without solving the matrices yet.